We'll see if that works. Okay, ready? Okay, so I have a few leftover homeworks. Everybody picked up their midterms, so we don't have any of those, but these are homework 2s and some old quizzes. You guys are supposed to take these because if you don't take them, I have to keep them for a year. That's the university rules. And there's still some beads left. You guys didn't take enough beads. So that's for later. So with respect to the projects, it looked like almost everybody had put up some pretty interesting ideas or had attached themselves to other projects. If you're still looking for a project, or if you're looking for people on your project, there's a lot of great information on the Piazza page. So definitely be great after class if you go back and look through the other ones, see if you can attach yourself to some other project. Use the follow-up comments mechanism so that you can attach yourselves. And tonight, Jeff and I will read through them and add some comments and see if there are any leftovers that we need to clean up on. Feel free to email us if you have any specific questions. But it looked like there are a lot of really interesting projects and it looked like it would work out really well in terms of people getting attached to things. So I think it's going to be a very interesting set of things to hear about over the next month. Any questions about the projects for the group? Okay. So we had a few leftover things from the lecture on, I guess I should have gone down to the right place. From this one. Missed it. I think. Sorry. So one of the videos I wanted to show was this arm in use, and so we have a. It got rid of the resolution again. So here's a video of that the phantom arm being used as a drawing package. So you can see here the arm, and he's using the 3D aspects of it. You can go at things from different angles. There's a button on the side that he pushes every now and then to change modes so that he can grab the object and rotate it in 3D. I'm not sure what he's painting, something medical, I think. So, using the different modes, he's grabbing the device and or painting in it. So just kind of showing you the different choices. We had gotten down to, I guess we were around here. So the idea of the 3D miniatures, as we talked about, one of the big problems in 3D is controlling the camera. And often it's very confusing that if you're in a room, you have to move yourself, plus you have to move the camera, especially if you want to see where you are, so you want to see yourself. So in games, obviously there's a lot of AI behind the scenes that's trying to point the camera over your head so that you can see yourself, except for first-person shooters where you're supposedly just seeing through your eyes. So this miniatures idea was that there was the big room that you were standing in, and you got a little copy of it, and then you could pick up yourself and plop yourself down in different places, kind of like you would do in The Sims or something, in order to place yourself. And then there would be this really cool animation where the little version would zoom out to be the big version. And then you can get another copy of the little one again. So it helped you understand where you were pointing. There's remember we talked about having a data glove that can measure your pose. And so in this research, they're using the pose of the hand and as well as its position to have a number of different interaction techniques. So when your hand is like this, it was a selection, a scaling gesture. And so he's using that in order to select an object and then change its scale, change its size. And what happens is in the virtual reality goggles, you actually see a copy of your hand, and so you can kind of see where it's what it's affecting. This is a generalization of the handles around objects. And so this cube put over this object, and these colored sections, so these are blue and these are red and this is green, and then the ones around the back I think are a different color, are actually handles for moving the object. And I have a video, but my computer crashed, so I can't show you that. But basically it's kind of what you'd expect. When you click on this one, then you're moving this particular handle, and the object moves accordingly. So that was a way of manipulating an object in 3D, and then you can rotate it if you need to get to the handles around the back. So this was a really interesting system. In all of the previous systems, you had to very explicitly say where you were drawing and on which plane you were drawing and things like that. But of course, anybody with any graphic design, see if the pen is here somewhere. Anybody see the pen? Lots of erasers, no pens. I should bring my own pen. So if you were drawing in 3D, you can just draw a cube, you can just draw a house, and the person that's looking at it would recognize it, as a 3D shape. And so the idea of this system is that it does that automatically. You just draw things like you would if you were drawing it on paper, and the system tries to infer the 3D shapes from the drawing. So it's a pretty cool system, and it lets you much more quickly draw these things. It's called constructive solid geometry, which means that you're drawing, it's kind of like Lego or something. You're drawing with little blocks. And in constructed solid geometry, you have basically two operations. Add a geometric shape, you can add this triangle shaped thing or a cube shaped thing, or you can remove one. So you can cut holes in things. So that's basically adding or subtracting shapes. So if you want this window here, you basically subtract a rectangular solid away from the wall object. And so it's called constructive solid geometry because you're adding and removing pieces. And the way that this system works is I just draw these pieces, and it infers what the shape should be based on what I'm drawing. And if it guesses wrong, then you can adjust the angle of the lines that you're drawing. And he has circles and straight pieces as kind of the primitives that you can draw out of. So it's somewhat limited in the sense that you can't draw arbitrary shapes, but it is much more fluid than the kinds of things that you'd normally do. And I think maybe there's a video at this link, because this one's kind of fun to see. We'll see if there's the video here. Well, no, just the paper. Oh, well. I'll try and see if I can get the video up if we have time. This one, luckily, the video's on YouTube. So this takes the same idea that we just sketch things and applies it to soft, roundish shapes. So remember the previous one, you could only do, circles and rectilinear objects. So this one is designed to do plush shapes like teddy bears, snakes, all these continuous smooth curves. And Takeo is an amazing system he did for his PhD thesis that does a lot of the mathematics so that you get these nice round shapes and very clever interaction techniques so that it decides based on what you draw whether it's an extrusion, a thing that sticks out like an arm, and where it should attach to, right? Because if you just draw this little curvy thing, it could attach kind of anywhere on the shape as it exists. So you show how it attaches. And you can cut holes in things and show how these different pieces are connecting. So here he has this shape. and he draws a circle. So far, that's just a circle, but it's on the shape. And so when you rotate it, you can see where it is. And then he just draws this piece, and because it connects, he assumes that that should connect as a circle on the base, so it makes the horn. And then you can erase this line, and it makes a smooth curve. So let me show you how that works. It's very compelling. So was this on a different tab? No, that was the one we just watched. Nope. Was this relevant? No. Ah, good. Okay. Let's see, volume.
Freeform models such as stuffed animals. The user draws 2D freeform strokes interactively, and the system constructs a 3D shape automatically. This demonstration is running as a Java applet on a standard PC. I will introduce the modeling operations one by one. When you draw a closed stroke on the blank canvas, the system constructs a 3D model by inflating the closed region. The algorithm is designed for the construction of round models, and it creates various naturally looking shapes. This is a snake. Our algorithm makes wide area flat and narrow area thin. This is a dinosaur. This kind of modeling required many operations in previous systems. This is a snail. We use real-time pen and ink rendering to encourage creative exploration. You can draw lines on the object surface by drawing a stroke within the object. Camera position changes when you hold a button on the stylus. Scribbling gesture on top of the surface line erases it. Extrusion is a two-stroke operation. You first draw a closed stroke on the surface, and then draw an extruding stroke. This is basically a sweep operation. With it, you can create various shapes, like this long extrusion. This is useful to create an arm or a leg. Or this fat extrusion. This is useful to create a head. And this thin, plate-like extrusion. This is useful to create a wing or a fin. You can also dig a hole using the same operation. The resulting model is always topologically equivalent to a sphere. You can cut the object by drawing a stroke that crosses the object. With the same operation, you can also take a bite out of the object. This is useful to create a mouth. Cutting stroke makes the cut section red, and you can extrude the section by drawing an extruding stroke. If you want to remove unnecessary bumps, draw a closed stroke around it and scribble. Then the system constructs a new smooth surface. This operation can be used to remove a crease to smoothly merge the extruded surfaces. When you want to bend the model, press the bend button to start the bending operation, and draw a reference stroke and then a target stroke. The system modifies the shape of the model based on your strokes. You can use this to deform your model in many different ways. we have started a user study of our sketching interface. We first give a brief tutorial and ask subjects to construct 3D models looking at some stuffed animals. As you can see, we found that even a child can enjoy 3D modeling with Teddy. She constructed this elephant after 10 minutes of tutorial and practice. Finally, I will show some example 3D models. They were created using Teddy by an expert and painted with a commercial texture map editor. Note that these models look quite different from typical 3D models because of the hand-drawn nature of the shape. This is the end. Thank you.
So Takeo's a very creative guy, and he's gone on to do some more work in a similar vein. But this is, some fairly, still quite old work at this point, right? It's.
Has it gone anywhere, like commercial?
I actually don't know the answer to that. I would certainly imagine so, but I don't know what sort of capabilities are in modern 3D tools like Maya or Design, or whether they have this kind of ability in them. But it is 15 years ago, so I would certainly imagine there's kind of things are available somewhere.
I think ZBrush may be the closest, but they don't have all the tool set this does even now.
Yeah. So yeah, it's a lot of fun. I think some of this stuff is available to play with if you're interested. Okay, so that was some little stuff I wanted to cover on 3D, and now Jeff's going to talk about games, game controllers, and also consumer electronics.
If you want to see more like this, SIGGRAPH is definitely a really cool conference to check out. There's always really cool stuff coming up every year from there. And WIST, UIST, is more on the user interaction side of things. And it's really cool to read some of the proceedings of that because they do crazy things like soft, squishy displays. It's wild. So we'll switch over to here now with any luck. Do I get presenter mode? Awesome. Okay, so today is going to be both games and consumer electronics. I'm not going to cover either completely because obviously it's a giant area. The goal is to kind of give a survey of some interesting issues. So don't necessarily take notes on every single game I mention, every single thing like that, because it's not that important. The thing to take away from this, I think, are trends and kind of the general themes of interaction in this different space. So in general, consumer electronics are designed kind of for everyday things. They're inexpensive. The everyday person could afford them. These are middle-class objects, as opposed to something that only a university could buy. And they're used for a really large variety of purposes. Your microwave is a consumer electronic. A game console, what you play games on, is one. A paper shredder is a consumer electronic. So the scope is really, really wide. In this case, I'm going to start by talking about television, because televisions have had at least 80 years of development as a consumer product in some form. They really hit the mainstream right after World War II. And this is an advertisement for an RCA television, which came out shortly after the end of World War II in America. It retailed for about the price of a good used car, which meant people could actually afford them. And of course, black and white, tiny screen. We're only talking maybe this big, maybe even a little smaller. But you could now watch sports on them, and that was super exciting. Broadcasts in America didn't really start all the time until like 1949. So even if you bought this device, you may not always have television signal to watch because they may not be airing 24/7 and there may not be many channels at all. So the question came up pretty much immediately after television started being in everyone's house of how do you control them? They always had knobs in the front that you turn. We don't see that anymore, but that really was a thing. But people don't want to get up. Obviously, sitting on the couch, this is a problem we have today. So in the early 50s, the company Zenith started out with a remote. This is an ad for their Lazy Bones remote, which is one of the first. And you can see it in the upper left corner. It looks kind of like a clicker device. There are two buttons on it. You hold it in your hand like this. And it's basically channel up, channel down. And it's hardwired into your television. So you could only be so far away, and it would always be kind of sitting on the floor somewhere. And this worked really, really well, actually. You have a hard connection. It works great. And you only have two buttons, so you really can't make a mistake. People figured out how to use it quickly. People know how to use it. Of course, that shape that kind of fits in your hand doesn't sit so well on a table or on a couch, and it would fall off, but you have the cable to find it again, so it's all fine. Early televisions looked like this. So you have the tube, which is this big glass thing here, which is what the picture comes out of, and a bunch of vacuum tubes, because this is before digital electronics. There were no transistors. You had vacuum tubes to do sort of the same thing. You didn't even have a digital tuner. So what this means is in order to change the channel, you actually had to physically move a part inside the TV. And so all these early remotes actually activated a motor inside of these to physically turn the knob, because you couldn't even just do it mechanically inside. An early TV remote, once we go to the wireless age, about 5 years later, this is the mid-50s now, is called the Flash-O-Matic. And really, this is just a flashlight branded with Zenith on it. You can still find Zenith TVs, by the way. They're just not that common anymore. It kind of became a lowbrow band. But Zenith, for a while, was at the cutting edge of televisions. So the Flash-O-Matic was really just a flashlight with a trigger. But the gimmick was each corner of the television had a little light sensor on it. So you could aim the flashlight at different corners and do different things, like power the television on or off, change the volume, change the channel. Actually, I don't think you could power it on and off. I think you could only do volume and channel, because the sensors weren't live when it wasn't powered up. The problem with this was if you turn your lights on and off, the TV may do stuff. No joke, it really, like you could use a flashlight, because it was just a flashlight, obviously. You could use anything, and it would kind of change and do weird things as a result. And also, you had to lift up your hand and get the aim just right to make sure you hit the sensor. So it's kind of strange, but that actually was a thing for a while. About 2 years later, we get what we commonly think of as the remote now. So this is a biggie. In 1956, the Zenith Space Command remote. This actually has no electronics in it whatsoever. What's inside of it underneath each button is a little rod that hits a tuned piece of metal to make a sound. It's in the ultrasonic range, so you can't really hear it. But I mean, you can hear the clicking part. So you can't hear the sound that's telling the television what to do, but you can hear the part that triggers the mechanism. And so the idea is the TV has a little microphone in it. It's trying to listen for sounds. And when you press the right thing and it makes the right ultrasonic sound, then your channel goes up, your channel goes down. This is great. You don't have batteries in a remote. It's interesting that this technology didn't survive, because it doesn't require batteries. It just works. A weird thing is actually xylophones could trigger this too, and a bunch of musical instruments. So people who played instruments would occasionally have their TV do weird things, because it's sound-based. Another thing is that the term clicker, which you sometimes hear as a euphemism for a remote in the United States at least, is because this thing made a lot of clicking noises as you used it, because of all the mechanisms going and that kind of thing. But you can see the interactions are really, really simple here. It's all modal. It's really on-off. Press the button, thing happens. And the feedback is quite obvious because there may be a motor changing the actual tuner dial. There may be the volume going up. It's really clear what's happening. It took a while for electronic remotes to really hit the mainstream, and this is because technology sort of had to catch up in some ways. Transistors had to get small enough and cheap enough. Light-emitting diodes to make emitting infrared light, which is how most remotes work now, had to be developed and had to become cheap. So in this is actually 1980. It looks kind of like a 70s piece of electronic, but it's from 1980. It's for a cable box. The ViewStar cable box was one of the first really successful infrared remotes. And the idea here is instead of using sound or light or anything like that, we're actually going to use infrared light and just broadcast it to the room and have a sensor that picks up a certain pattern. So you can imagine it's kind of like Morse code, where you have some flashes, sometimes where there aren't flashes, and the TV can figure out what button you're pressing based on this pattern. The weird thing with this remote, they really didn't know what to do with these yet. It's hard to see on the screen, I guess, but 0 is down here, and it goes 1, 2, 3, 4, then 5, 6, 7, 8, 9, 0, or 9 is down here. So it's kind of this weird arch. You've got some menu control buttons up here that are dedicated, some volume buttons over here, and some more other random ones down here. So you already see there are, 5 times as many buttons in this remote as there were before, and that creep is only going to continue. But this was nice because now you could just point it and it would just work. And it was electronic. It very much fit the 80s aesthetic of kind of removing wires and using all the technology you have. Of course, we get to today and things are pretty crazy. This is the remote I have at home, actually, although I think mine's older and it has more buttons at the top. But you can see they're kind of busy. One reason for this is because consumer electronics have kind of merged together. So in the olden days, you may have 10 remotes on your table, one for your stereo, one for your VCR, one for part of your TV, one for your cable box. And you'd end up with this huge pile of them. These days, the tendency is to merge them together. So kind of in the middle of the remote, you have VCR controls, which are now just a DVR inside of your cable box. You've got all sorts of menu navigation controls now because on-screen menus are a big deal. And they finally, after 40 years, picked up on this number pad thing because, once again, touch-tone telephones were big in the 90s and are now kind of the norm. It's interesting that now they're even putting advertising on your remote. So for instance, this button takes you solely to kind of an ad-provided service. So the use case of the remote is expanded, and kind of the amount of interactions you can do just in this device has gotten pretty darn enormous. It brings up menus, it navigates, it changes, but of course volume and channel are still there. The ones that worked on the Space Commander way back when haven't changed at all, and they still behave the exact same way. So key things to think about, it's all modal. Almost everything you do is instantaneous, although that's changed lately these days. As the technology for wireless has gotten better, the remotes have kind of immediately picked it up. And of course, things are getting more complex and things are kind of merging together, making them more complex. On the display side of things, of course, the original display you had was actual knobs, right? There's a motor turning the tuner. It's going to change the knob. You're actually going to see how it looks. Not terribly exciting, and that was pretty much the standard for a very long time. The reason for this is partially because of how TVs worked. They didn't really have the signal processing and computing ability to modify what's coming in from the TV. Basically, over the air, it would feed exactly what shows up on the screen, and it would just kind of pipe it directly to the screen. No extra manipulation. It took a long time for them to be able to kind of insert displays like this on top of the TV signal and manipulate it. And for a while, you really just got something like this. This is more new, but in the 90s, you just imagined that these numbers were white with a black border around them, and that was like the thing to do. And they could at least add numbers on top as some sort of on-screen display of your current status, partially because they were getting rid of those knobs as well to try and make them look more appealing. And now all of a sudden they face the problem of there's no knob to tell you what channel you're on. How do you do it? We'll just make an on-screen display that'll work. Following this trend of complexity too, this is an early style TV menu, probably from the early 90s. And you'd actually use weird buttons in your remote like channel up, channel down, and a whole assortment that doesn't make any sense to try and set these different options. It almost always was the case where you just highlighted one and selected it and could possibly toggle it. It would pop up over things, but the content underneath would still show. And these were at least simple, but incredibly hard to use because they weren't really following any convention, and every manufacturer did it differently. There was no standardization like we see in computers just because every consumer manufacturer did things so differently. Of course, today it's much worse. This is the menu I have on my Samsung TV. And you've at least got icons and some kind of hierarchy. They're at least learning a little bit from what we've seen in computer interaction techniques. And they've made a hierarchical menu, but the same still holds of what buttons do you use? How do you actually manipulate this? This menu is nice because it kind of scrolls through things and has pop-ups, but that adds more complexity that maybe should not necessarily be on a television screen. A new trend you're seeing too is to actually merge devices together. So I have a media PC at home, and one thing I can do is use an app on my smartphone to get almost the on-screen display of the television, but make it interactive. So now I can explore the music on my phone, cue it up, and it'll be on the TV immediately without having to use a remote at all. And you'll see this more and more, I think, as we kind of get used to, I hate to use the buzzword, but Internet of Things. This is going to be more and more common, I think, where we merge on-screen displays with the existing things you already use. And for more on that, I think you should stay tuned for Chris's lecture in a couple weeks, because Chris is all about kind of merging all these technologies together and just unifying it. And so with menus, simple is the name of the game, but things have gotten more complex as televisions can do more and stuff is combined. Not an unexpected story, but good to see visually nonetheless. And of course, you see some picking up of the technology that's existing contemporarily in computers. Pop-up menus and hierarchies in menus did show up around the time that computers were starting to really have hierarchical menus, things like that. In consumer electronics, there are a ton of other devices to think about, and a ton with problems. I'll add text entry on a television is basically impossible. Not only do you not have a pointing device, but to enter text, you basically have to press up and down until you get the right letter, which is no good. And that really hasn't changed at all since then. Microwaves are a really huge area where there's terrible design and terrible interaction techniques. I can't emphasize enough how much designers fret on microwave design because it's so atrocious right now. On the left, this is I think it's from China, judging by the characters. I don't see time at all on here. Is there a time button? I don't speak Chinese well enough to really tell. But it's fascinating that you necessarily may not even be able to just cook something for a certain amount of time. Whereas this one, it has this huge array of buttons here that interact with the microwave in really different ways. So if you want to cook your food, do you want to cook it for a certain amount? Do you want a minute of time? Because there's a special button for that. Do you want an auto cook, which is different from every other microwave's auto cook? A really funny problem with what?
There are two that say auto.
Well, this one's auto cook 1 to 3, 4 to 6, and 7 to 9 because you need 3 different buttons for different numbers. It'd be horrible to press that 9 times. This is common, not at all surprising. A really funny thing that you'll notice do a compare microwaves with your friends game. No joke, it's really funny. Maybe I have a sad life, but that's something to do. Look at how entering time versus power changes from microwave to microwave. Some, if you put the power in, it erases the time. Some you need to put the power in before you put the time in. Some you need to put the time in after. It's completely inconsistent and it's completely unpredictable and they give you no feedback about it. The interaction is solely just through this usually 5 characters worth of display, and there is no feedback ever about what your order of operations should be or how it should work. I'll turn to human factors to talk more about how you should lay this out and how that should be. There are a lot of good books on that. I don't think Design of Everyday Things, the book, talks about this too much. They focus more on doorways. Perhaps if you cared more about digital technology, it would be about microwaves because it's a serious, weird issue. So enough about basic consumer electronics. Let's go into video games. I have some expertise in this area, but partially due to grad school kind of putting a damper on it, I may not be the most up to date. So if anyone is a gamer in here and comes up with ideas or notices things I haven't mentioned, by all means interrupt me. It'd be good to have some participation and kind of involvement here. For the sake of convenience, I'm going to divide everything kind of in early, middle, late. Early being kind of everything up to the 90s, middle being 90s to early 2000s, and late being kind of that time to now. This is not really any common way to do it. It's just an easy way to help us think about this and how things have changed. The required reading for the class was a book by Steve Swink. He's a game designer by trade, and he's very interested in what it means to actually have a game that feels good. Because you can make a game really easily, but making a game that plays well and is engaging is not at all easy to do. The area he's especially concerned about is kind of the center, and the key circle to think about in his description is this real-time control and simulation aspect. So he's interested in a very certain kind of game, a game that kind of looks like this. So this is Super Mario 64, and he really cares about games that have a character inside of a world that has some kind of simulation going on. And so all of the passage that you read very much focuses on this type of game. And that's good because a lot of games kind of are in these two circles. And polish, of course, is just kind of an orthogonal thing that you always should have. But there are other games that are worth thinking about that he kind of discards. They're simulation games. So here is Civilization 5, which is a bit hard to make out on the screen. But basically, this is a game where you have different armies fighting each other. You run a civilization. And so here a person is controlling a group of cannons, I think. And he's trying to pick a target among all these different red circled regions. And so you can see a lot of really common interaction techniques here too that are not at all like this simulation game. Notice there are no buttons here, whereas there are a ton of buttons in this palette over here on the left, and there's a ton of kind of display information in the lower left. So it points to one theme, I think, going on here, which is the genre of the game really does influence the kind of interactions you're going to expect. This isn't a really big surprise, but it's really stark, the difference between a simulation game like Swink talks about versus kind of a more polished strategy game like Civilization would be. For the sake of clarity, I'm just going to cover more of an emphasis on simulation games, kind of like Swink says, games that have a physical world, and are really concerned about moving, taking action, and possibly displaying your ongoing status. So you may have a character that you have to move, you may have some kind of spaceship you need to shoot, and you may need to show your score or something like that. And we're going to kind of look at these games through these different lenses, thinking about how you accomplish each of these goals given the controls you have, given the kind of screen you have, and so forth. So entering the early era, this is going to start way, way at the beginning. This is not what the game looked like. So this is from 1952, a game called OXO. What this is running in now is an emulator on an old Mac computer. An emulator basically, because the technology was so old, it doesn't exist anymore, so they can simulate it in some form. This screen over here was not actually a screen. They didn't have a screen in this computer at all. All it would do is print out lines to a piece of paper. So what they did, they used the actual memory of the computer. Before 60s or so, I want to say, they didn't really have memory like we think of it to store data. They actually stored data in tubes where things would actually move as a delay function. So they'd have tubes of mercury that are kind of changing position and moving around. And one day this guy noticed that he had a really nice grid, kind of in a square shape, of mercury tubes. And he thought, well, why don't I just make the mercury form a display? And so he made a tic-tac-toe game that kind of uses the computer memory to show tic-tac-toe to you. The funny part, if you look in this corner of the emulator, you see it says dial. The way the game would be played is it would print out lines like you'd see up here at the upper right corner, and then you dial in using a phone, like a normal rotary phone, what you wanted to do. So you'd first dial a 1 or a 0 for who's going to go first, and then you dial the number on the board that you want to play. And it would, of course, enter it. The mercury would move around. And so the interaction here is really simple. And all these early games, they're appropriating old devices. They're not willing to invent something new versus what they have in the lab already. So this is, the EDSAC is a computer that they had in this lab. There's already memory. They've already got a phone sitting there. They may as well just use that and try and make a game. And of course, XOXO, tic-tac-toe, games like that have been around for a very long time. So it's nothing they had to invent gameplay-wise either. They already had it done. A little bit more advanced is Tennis for Two, which is a game that was made in 1958. Whereas OXO, the previous game, was coded up digitally. This is actually an analog game. So everything is done using hardware in a very different manner. If you're a computer scientist, I recommend reading about analog programming. It's mind-blowing. But the idea is the display is the oscilloscope they had in the desk. This is a way for viewing computer signals, kind of seeing frequencies and different kind of data going through electronics. They appropriated it and made a tennis game. So you can see there's a tiny little line in the center, which is kind of the center post in tennis. And then you have little dots on either side, which are the players. And you have a tennis ball that bounces across. And to control it, you basically have a, let's just take this out, get this going, there we go. You basically just have a wheel, which kind of moves your character up and down, and you have a button to actually swing your tennis racket. They just made this, they had a box in the lab, nothing's fancy whatsoever. The controls are really simple, and the gameplay is really simple, and it's once again a game we already know. The only feedback you get is kind of this little tiny screen changing. There were no sounds, there was nothing else like that. Finally, we start to see actual displays come the 60s that people are regularly using. The PDP-1 came out from the company DEC, which a lot of labs started buying. And the PDP-1 was nice because you could program it really easily. And so a group of MIT students, this is before the Media Lab, before anything, as part of the group that coined the term hacking, would occasionally have these hack sessions where they would make things for their PDP-1. And one of the things they made was a game called Space War. The exclamation mark is part of the title, weirdly. The PDP-1 had a vector display, so you'll notice the ships are all kind of these really nice rounded shapes. It's really hard to see here, but you can look at the slides later. You have a wedge ship, which is this really pretty drawn shape because it's a vector display. They couldn't do a dot in their vector display easily, so the central star is kind of this line. And you have another spaceship which looks like a needle. It's just narrower. And the idea is this star is trying to pull the ships into it and crash. And at the same time, the ships are trying to fly around and shoot each other. And that's really all that happens. The system looks like this. So there's the display up there. And originally what they used were the switches on the PDP itself. So you can imagine this big tower of computer with the monitor in the center. And there'd be two people hunched next to it, flipping these little tiny switches on the PDP, trying to control the ship. One switch would rotate you, so if it was left, it'd rotate you left, and so forth. And the other would thrust, kind of turn on your engine or turn it off, and one would fire. They quickly wore out the switches in the front of the PDP and had to pay to replace them. So all the labs actually had worn out switches in their PDPs because this game spread across the country really quickly. So they ended up, pretty much every lab made these aluminum boxes that you can see here, which have copies of the switches in the front of the PDP-1 computer and a big fire button, to at least try and make it a little bit less harmful to their mainframe. If you're interested in playing Space War, they have tournaments, I think, every day at some time in the Computer History Museum in the Silicon Valley. Highly recommend going there anyway, but you can play Space War, and it's pretty darn cool. Around this time and continuing on for a long time, you also see another variety of game, which kind of fits with the technology they had at the time. These are the text-based adventure game. So you can imagine if you had a character display, what are you going to make as a game? You're going to make some kind of novel that you can play. Zork is a really commonly known one from 1977, but there are other ones like Adventure that came much earlier. And there's a huge variety of these. It was an explosion before 1980 of these kinds of games. And so the gameplay of this is just through a text prompt. You basically have a command line, and it feeds you different information. So you can see each one of these usually starts with a setup. It tells you where you're standing, and maybe tells you kind of what's currently in the scene. So in this case, you're in front of an open field, and there's a mailbox there. And you get to interact with your environment through commands. So in Zork, you have commands like examine, open, and get. And you can tell the game, I want to open up the mailbox. I want to find out what's in it, and so forth. Anyone have any thoughts of why this is perhaps not the best interaction technique for controlling a game? It's not hard, yeah.
Well, you would have to know what the commands are.
Yeah, and so it's kind of a funny thing about these games that they're infamous for having to guess the commands. Everyone tried to standardize these, and they tried to kind of imitate past games so you could figure out what the verb would be, because that's the first problem. Do you say examine? Do you say look at? And there was never any standardization that worked. A lot of times you'll see verbs like this, but they're not always the same. The next problem is, what's your target? Do you say small mailbox? Is that what the developer wanted you to type in? Do you say look west? Do you say look to your left? There's really no answer for this, and these games basically become a guessing game of trying to figure out what the developer intended you to do, and then trying to type in the right thing such that you actually do it. I highly recommend, if you're interested in the history of games and kind of these early interaction techniques, you try and find a game like this online. You can find them really easily. Just search for Zork, you'll find this one. And just try and get through the game and count how many times you kind of get the wrong verb or get the wrong entry as you're playing through. So the key takeaways for these really early games, I think, are the fact that they're almost always appropriating existing media. Tennis for Two uses tennis. OXO uses tic-tac-toe. Even Zork, the text adventure game, really kind of uses a storied history of choose-your-own-adventure novels, where you could kind of read a chapter, and then it would say, if you want to do this, go to this page. If you want to do this, go to a different page. And you'd kind of read through, and you'd get a custom story. They're all kind of botched together. So obviously we're seeing all these aluminum boxes with little controller knobs in them, which people have built themselves. It's much like the mouse in its first development. The interactions are always simple, and they're kind of familiar to what's already there. So you saw in Sketchpad there were kind of potentiometer knobs to control different things. That was a common thing throughout all of these early computers, and so they just used that kind of thing because it was familiar. The interactions are always quite simple. It's usually press one button, move one thing. Space War was cool because it had two different switches that you had to move. And arcades just start out then. So we hit about 1980, and arcades become the big time, but we're going to have to go back to 1972 or so. So Pong is the first major arcade game, and it's kind of the game you think of when you hear arcade. And it really, really is a simple game, very much similar to what I've been talking about before. It's hard to see in this slide, but you have a knob here and a knob here. So each player basically just has the same knob that we've seen for 2 or 3 decades now, sliding up and down a little paddle, trying to hit a tiny little box across the line and kind of get it into the non-occupied space on the opponent's side. You just stand side to side here and you'd play it. It used a really simple raster screen with really low resolution. The interesting thing about Pong is it's actually really, really complicated. So there's some really interesting quotes you can read online about how the developer Alcorn spent a huge time developing the paddles. So it turns out these little paddles that you see here, or here rather, the score is up here, we'll get to that in a sec. The paddles you see here aren't just kind of a reflecting mirror. They actually change the angle the ball is shot out at. depending upon where it hits in the paddle. And this is 1972, and they're already thinking about this, that if the ball hits right in the middle of the paddle, kind of in the center, it should reflect off 90 degrees away like you'd expect a mirror would. But if it hits way on the edge, like you're swiping it across, it should reflect at a more oblique angle. And his idea was this would give them some kind of sense of strategy. And so even with a really simple interaction, like swooping this knob, the actual act of moving and then taking the action of sending the ball back is really, really complicated and took at least 3 or 4 months of development to get right. Another thing is that we already see the development of the on-screen score display. So we've already got 0 and 1, which are the score values here. And this is going to be a theme that we're going to see start to develop because this trend really, really stuck. Hitting the big, kind of the big games now, things that really launched arcades as a place to go in the 80s and a multi-million-dollar, multi-billion-dollar industry. Space Invaders was a huge, huge thing because in 1978 they really didn't have arcade games of this sophistication, and now all of a sudden you have a game that looks colorful. So you see there's green down here and white or sometimes orange up here. The screen was not actually color. What they did was spread cellophane across the screen in different colors to give it the illusion of being a color game, because obviously you didn't have a color display yet. We'll get to a video next, but you'll notice that they give really obvious descriptions of the controls here. This is a very common thing in arcades. Obviously, discoverability is a big issue. You're putting a quarter in to play the game. You need to know how to play it immediately, because otherwise you've lost your money. And so almost all of these games have these really rich displays next to their controls to try and tell you what to do. This right here is a joystick, very common arcade thing to have this big knobby sphere. And it actually is not rate controlled. I'll let you know when we get to rate controlled joysticks, but everything you're going to see so far is all digital. As in, you turn it, it's on. You go back to the center, it's off. There's no kind of fluid movement between. I'll let you know when that changes, but otherwise it's all going to be just kind of this on-off digital joystick, which is really interesting for the design of games. Another thing to think about, too, is how to make these strong enough to survive actual play. So you'll notice they've got these really big kind of ABS plastic buttons, different colors, and really knobby metal back joystick. They're built for abuse. This is something we're not going to see once we get to kind of home game consoles, but this was a really huge concern for arcade owners back then. These games cost a huge amount of money, a staggering amount of money, because the computers inside of them were all custom. Each board that went into these arcade games was almost unique in a way to the game, and therefore it cost, at least in 1978, a pretty good amount of money to get right. And these modal buttons, as I recall, were for player setting, but I may be wrong about that. So if we look at Space Invaders in actual play, you can see pretty easily how the joystick is used. We start out with this on-screen display, which is pretty cool. This is not the original Space Invaders. This is a recreation. Oh, shit. That's good. So much for the video. Anyway, we'll start to see already kind of on-screen displays happening where they're going to give you score now, because the arcade is a social space. And this really changes how gaming is done. So before you'd have a thing like Space War, where you'd have two people who are computer scientists sitting next to their PDP-1 trying to flip the switches. And that, frankly, I'm waiting for the little bar to go down, don't worry. That wasn't terribly exciting, and you probably knew the person, and you were only going to play it one off, and then it was going to be unloaded from the computer forever, because these computers could only hold one program in their memory anyway. Now all of a sudden when arcades come around, you actually have a social space where people are coming and going. The computer is always on, it's always running, it's always storing data. So now all of a sudden the social proof of having a high score becomes really valuable, and it makes people pay more money. The goal of an arcade, of course, is to get more quarters into the machine, and one way to do that is to make people feel like they've accomplished something. So all these arcade games you're going to see will have a high score bar at the top, and this is simply because they wanted to make more money. People will come back and try to beat the high score, and because they're always running, they're going to be able to do that now. We'll come back to Space Invaders in a bit. Another game you probably heard is Pac-Man, which I don't think I need to show the slide for, thankfully, because it's something that's pretty common. But Pac-Man was only controlled with a joystick, and it's the same kind of digital thing. You'd think it'd be really exciting to have a rate-controlled stick where you could imagine the character moving slowly or really quickly, but that was not the case there. Let's see, projector, yes. Doing its thing. And Pac-Man's interesting because it was so successful in the 80s. It's commonly thought of as one of the things that launched the so-called golden age of arcades. Not much to say about the game itself, truthfully, other than the fact that it has the same kind of on-screen display we've seen before, and the fact that it's using all 4 dimensions of the joystick now, not just the 2 to move the ship like it was in Space Invaders. Almost ready with this green bar of awesomeness. So we'll get back to Space Invaders. I want to show a laptop, and I want to actually show something. Cool, this is working now. So here's Space Invaders. This is a newer version, so it has fancy graphics here. This would have not been in the original at all. But at least the colors are pretty good. And you can see here's a person playing now. We've got really interesting on-screen displays already showing up in 1978. We've got the high score. And so it's kind of just a simple raster character. And you've also got these visual indicators now of you have 2 ships left, so therefore your ship is there. If you look carefully at how this little weapon moves, it is a digital joystick. There's no rate control here. You don't move it faster or slower. It just either goes or doesn't. As an aside, there's a reason why these Space Invaders get faster and faster the more you kill. And it's not because the designers tried to make the game harder. It's because when there are this many on the screen, the computer can't keep up. So it renders them slowly. And as fewer and fewer of them show up on the screen, it can go faster. It can draw the screen faster and process what's happening faster, and therefore it speeds up. The designer just thought that was a good idea, so he left it in saying, it's increasing difficulty. I made it happen. Cool. And so there's a really interesting trend in the arcade games, too, of weird things happening as they're coding it, and they just decide to leave it in because it ends up being a really good way of playing the game or way of interacting. Cool sound effects, too. I'm going to turn those off because I don't know if anyone's speaking over these videos or who knows what happens. It's YouTube. You also see, of course, another common arcade thing, which is the number of credits you have left down there, because obviously you're putting quarters in, and that's important. Here is what Pac-Man looks like for those who are unfamiliar. Some lovely art, once again, at the bottom. Arcade art is always really interesting. They're telling you what to do because discoverability is always a concern. These are people who are just walking up to the game, so they're going to tell you, here's how you move. And of course, no one really knew what a video game was at this time either, so you really needed to tell people this is what move is, or have someone kind of stand by and watch to learn the game. Around 1984-ish is when arcades start to die off and we start to actually see consumer game consoles really come around. This right here is the Atari 2600. It actually does have real wood veneer on the front. This is not plastic. And a bunch of switches and a bunch of other things. We'll look at the controller in a second. But basically a game cartridge would slide in the front, right by where it says Video Game Computer System, and then you just go ahead and play it. And this is a miracle. Instead of going to the arcade, you could just play 10 games in your own house, and they would all be right there. It speaks to the fact that Moore's Law has miniaturized everything a great deal. But getting down to controllers, because we can finally really do that. This is not the Atari controller. This is the controller for the 1970s Magnavox Odyssey, which is one of the first consumer game consoles. And the Odyssey was all about kind of games on a 2D plane. So you had tennis, where you kind of moved across a tennis court. You had a football game where you kind of moved a football player around. And so their controller, they thought, should help you move things on a 2D screen. So this right bar, or this right knob, moves you up and down. This left knob moves you left and right across the screen. And you notice it says English here. It's the only thing they could think of for this little tiny knob, which puts English on your character, which means rotates it, I think. And so you can imagine trying to play this game. You have to set this on a desk, and then you have to rotate these knobs in a weird way, like an Etch-a-Sketch, to try and move your character in the right place. People apparently got really good at this, but everyone panned it as being really awkward. The knobs kind of broke easily because you were constantly turning them and twisting them. This didn't have the strength that the arcade games did, because it's made of plastic, and kind of cheap plastic. And of course, it was also wired. You can see the old-style cord right there. If we switch ahead to the Atari 2600, things are much, much better. It's very similar to the arcade. Obviously, we have a stick and one button. And it's nice because it's so simple. This is, once again, digital. You can only go forward, back. There's no rate control. The problem with it is, in some ways, that it's not like an arcade. It turns out people constantly broke these because they grab it with a fist because it's so comfortable, put it on their table, and then try and rip it to the side because they're trying to move really quickly. And they would break the stick in two. They're used to arcades where that wouldn't be the case, where the controls were designed to be rigorous. Now all of a sudden transitioning to home equipment, you can't really do that anymore. Another funny thing is that one button turned out not to be enough. So you can imagine for a really simple like Space Invaders kind of game, you just need to move and fire with one button. But programmers want to do much more than that. They wanted you to be able to jump and fire a gun or something. And you couldn't really do that with this simple Atari controller. So one thing they started to come up with were corded inputs, which you don't see often in a computer, but you do see very commonly in video games. So for example, holding up and pressing the red button to fire may do something completely different than pressing the red button or just going up. Programmers also started using these switches on the front to do different things. You'd actually have to reach to your console and flip a switch to do something, which is kind of strange. So this retailed for about $1.99. It was originally sold in Sears. And strangely, for a lot of these early consoles, there really weren't games that were designed for the console. There were much more games that showed up in arcades and then were later transported into the console. So you can see Pac-Man here and Space Invaders, which are the most popular Atari games, as I recall. And these are obviously just from an arcade, directly in. The controllers match up. It's super easy to do. Space Invaders is really what made this game, or what made the Atari popular. And for about 5 years, it was selling a crazy amount. To teach people how to play the games, they had really fancy graphic manuals. We're talking like booklet-sized things with really pretty art. Because obviously, not only did you have to tell people, right moves a little ship right, but you also had to tell people what the things in the screen meant. This didn't have really good graphics. So if there's a square on the screen, you've got to tell people what that square is supposed to be. Is it a person who's like a soldier trying to run through a forest, or is it like a ball being thrown in a tennis game? They actually had to describe to you what you should be seeing. And obviously, this is kind of referred to as the home gaming revolution because just so much was purchased in that short amount of time. Everyone bought an Atari, even though it was pretty pricey. $199 is a price you're going to see it often. In $1978, that was a pretty good chunk of change. One game we can look at in detail is Activision's Pitfall, which is one of the most popular games for Atari 2600. I highly recommend you play it if you get the chance. There's a really rich community online of emulator people. In other words, people who run software that imitates these old consoles on your new computer. I highly recommend you play some of these old games because it's really interesting looking at how interactions have evolved since then and have changed over time. Yeah?
On that note, archive.org actually now has a whole section of that uses a JavaScript emulator for
Wow.
a lot of old games.
That's totally awesome.
Yeah.
I recommend doing it because it's the key with things like this is you're not only looking back into gaming history, but you're also looking back into computer history because they're copying the metaphors they see on computers all the time. And so it's interesting to see kind of what was the state of the art for interacting at the time, at least what the game designers thought, because they're trying to be current. Yeah?
Can you repeat that? What site is that?
Archive.org, which you should know anyway because it's an awesome site. Everyone should know about it. They archive everything. So you can see kind of similar things from the arcades. We've got little people here to stand in for how many lives you have left in the game. We've got kind of a time counter. Pitfall was a game where you kind of had to run, avoid things like this log, which is going to damage you and take away points. The goal was to get to the end of the screen and get all of your points, kind of keep all of your points together. As you continue on and take more time to do it, you lose points constantly. So the idea is to be fast and accurate. And so the interactions for this are really simple. You basically have a button to jump and a button to go right and left with a joystick. You can go up and down these fancy ladders. So this was a big innovation at the time, was the fact that you can go to a subterranean level here with the down joystick and actually explore these caves, but still go to the right. So the idea is they're expanding the interaction space a little bit by exploring and experimenting. We're not just using the left-right fire thing like Space Invaders did. We're trying to simulate new things. We're trying to use different actions for the same button. That's about all I'm going to say about Atari. There's a lot more to say about the system and the development of it. Atari as a company pretty much crashed and burned. Everyone thought that consumer electronics and game consoles in the home would be gone forever after Atari died, because Atari blew up so cataclysmically. But it turns out in the mid-'80s, Nintendo actually did come back around with something that sold really well. So Nintendo is a game company, but it's actually been around since the 19th century. They made cards for a really long time. And you can actually still buy Nintendo playing cards if you want in Japan, which is kind of bizarre. But they realized pretty early on that you could make game systems that people would want to buy in Japan. And they also realized that North America had a really good market for it too. So they sold one for, this is the North American one, it's called Famicom in Japan for Family Computer. And this retailed for $199 also. So even though it's retailing for the same amount, it's getting cheaper obviously because the dollar is inflating and things are costing more in general. Joysticks are no more. One of Nintendo's big claims to fame, and actually a patent, is on this directional pad. So they realized the joystick is only turning things on and off anyway, so you may as well just make a little pad that has buttons underneath it that does the same thing. You'll see this commonly referred to these days as a D-pad, short for directional pad. You'll also see they've added control buttons now because they realized people were using all these switches in the front of the Atari to do things. Why don't they have little control buttons for any kind of game that appears? And of course, one button wasn't enough. 2 buttons probably is good enough. If you have more than that, it's going to be confusing. So you better only have 2. And this is exciting now because a wide variety of games can be supported by this simple controller. It's not terribly ergonomic. It's not terribly designed for your hands and how your fingers work. But the important part is it has a lot of buttons on it now, and you can actually have a variety of games. So this is Super Mario, or Mario World 3. No, Mario 3. Super comes later, World comes later, I think. Anyway, this is the 3rd Mario game for Nintendo, the original system. It was based on an arcade game. So Mario, the original one, was an arcade game. Then it became a port into Nintendo, so they brought it in there. And then they keep devolving it because they realized it was making them a ton of money. The basic mechanics have always been the same, which is you can move left and right, you can press a button to jump, and you can jump on things, like this character here, a Goomba, and you can jump onto boxes and hit the boxes, which lets off amazing power-ups and other things. This game is notable because they're really adding a heads-up display now. So you see, not only are they showing score, but they're really trying to make it visually appealing now, their displays, and they're also trying to make them sensical. So you have time here, you have the amount of points you've scored, you have this P meter, which is a gameplay mechanic that lets you kind of soar up into the clouds. You have status of kind of where you're at and how many lives you have, how many times you can play. So things get really complicated really quickly when they realize this system is really powerful. But strangely, we don't see too many menus. Most of the menus that we see in this time are just modal things that will pop over, and you may have a few controls. There's no tabs, there's no kind of separation or hierarchy, at least not especially. Things are very modal. Another addition here too is the fact that Mario can change modes as well. So now he can put on costumes and be in a different mode, which changes the way the buttons work. This game is often hailed as showing one of the really nice features in the Nintendo controller. So if you look at the way these buttons are labeled, this is B here, the left button, and A is to the right, which is kind of strange if you're an English speaker. A should be on the left, then B. One argument why people say it's the case is because B is the button that comes second. It's the button to run. It's the button to do something else. A is the button that does everything, like jump. And so Mario capitalized on a really interesting kind of human factors property that you could easily put the tip of your thumb on B to run and then angle your thumb to press the A button as well. So they're using chorded inputs here, where you can press both B and A at the same time to do kind of a complex action. And they're designing the object so that it really works with that. So really all you have here are move, left or right, jump, and run. Only those buttons. It's really simple. But it gives you a really wide, complex array of actions you can take because you can combine them and because you can kind of do multiple things at once. Another game that's worth thinking about at this time is the original Legend of Zelda game, which came out to huge acclaim. It was a revelation. And you can see here that they're making full use of the directional pad now. So to move your character, it's in a 2D area, but unlike the Magnavox Odyssey, you just tell your character which direction to go and it will. It's a wide world to explore, which means they have to show kind of where you're going each time. It doesn't just skip into a new area. It actually kind of pushes you in there so you can see where you're going. A big thing to note is this heads-up display on top. The Zelda games are notable because they have you use a variety of different tools. And so the question for the NES designers were, how do we show what tools you're using now and what tools you could be using? And so their answer is actually to mimic the controller. This is something you'll see often done by Nintendo, not a lot by other companies. Their on-screen heads-up display will show you the controller itself or something like it. And so you can see the A button uses a sword, the B button uses a bomb. and it's really obvious what's happening here. There are menus in this game to kind of select what you're doing, but they're not too major. One thing that's interesting that comes around this time, it was present in arcades, is the need to enter in names. So in arcades, obviously, if you had a high score, if you were the best person in the arcade, you wanted to share your name. So the common thing to do would be to give you this rotating series of letters where you could kind of page through it left and right, find the letter you want, press the button to select it. The innovation with something like the Nintendo, which lets you go up, down, left, right, is that you could do this kind of grid keyboard. And now all of a sudden you can put in a bunch of characters really easily. They hadn't come wise to the fact that a keyboard doesn't look like this. They just kind of ordered the letters the way they thought they should be ordered. This also may be an aberration because of the fact that many of these games were created first in Japan. Another interesting interaction that comes out of this Nintendo system is the evolution of other controllers. So Brad talked about the Power Glove, which failed terribly, but was a very interesting development for a really early system. Another interesting thing is the Power Pad, which if anyone's played Dance Dance Revolution, it was very much like that. It had a plastic pad with different buttons you could step on and actuate different interactions. There were only like 2 games that used that either. The big popular one, though, was this so-called light gun, which is not unsimilar from the light pens that were used way back in Sketchpad. Inside the light gun is a little light sensor. It's not doing anything fancy. When you pull that trigger on the gun, this screen wipes completely, and it projects a white box where the duck is that you're shooting at. And the idea is if the gun sees light, then you've aimed at the white box, therefore you hit it. If the gun doesn't see light, then you're aiming somewhere else in the screen during that flash, and you probably missed it. And then it goes right back to the screen so you see what's happening again. It happens so quick you probably don't notice it, but it's a really low-tech solution to try and keep costs down. So this is nice because it's much more naturalistic now. It's really, the interaction is grounded not just in kind of pointing, but also in the activity you're doing. And this is a very common game thing, which is to kind of not only accommodate the task, but also kind of make it naturalistic in some way. A funny thing about this game, Duck Hunt, though, was you needed a second controller put in the console. So you could use this gun to shoot ducks, but you couldn't use the gun to control the menu that the game started up with. You had to plug another controller in and press a button to toggle between these different game settings down here. Game A, Game B, Game C. And so it's funny that they weren't able to make this pointing device work for the different game modes, but yet they could make it work for shooting at this thing. You'll see these a lot in kind of early Nintendo-based games where the affordances don't really line up quite yet because they just can't make the technology work fully. We'll skip now to what I call the middle era, which is once again my own arbitrary distinction. It's a really good game, Seiken Densetsu, but it emphasizes the fact that there's a lot of really interesting new games coming out. They're less concerned about arcade ports because the arcade had pretty much died at this point. Nintendo was the final killing blow to them. Everyone just bought a game console in their house and played it. And so for the latter half of the 80s and early 90s, arcades weren't doing terribly well at all. As a result, that meant that these game developers could no longer just borrow arcade games and make them work in the home. They had to come up with new, different technologies and different franchises for people to play. And this meant that they could explore a lot more. And one thing that helped was the fact that the Super Nintendo, which coincidentally also retailed for $199, but was much more powerful, now has 2 new buttons. There's still B and A, just like Nintendo's old one. There's still Start and Select. It has Y and X now up here, and it has shoulder buttons, buttons that you could hit with your index fingers on the top of the controller. And what this means is now Mario can do more things. So instead of just moving left and right and jumping and running, now he can do a special jump where he spins. Now he can shoot fireballs more easily. And the idea is that as the controllers gain more buttons, it tends to be that game developers add more functionality to match what the controller can do. They tend to expand into whatever new input space they have available to them. Another notable thing is that now they're trying to show motion much better here. So you're moving left and right and your character moves, but now they spend a huge amount of time trying to get the camera to look right. So where's the camera going? Is it centered on Mario? Is it looking somewhere else? How do we show motion? So it turns out this back panel, kind of the background, moves right at a slower rate than this does to kind of give you an illusion of depth. So there's a lot of really clever, simple things they do to try and make the movement interaction and the jumping interaction feel more natural. There's a video, I think, linked in the course page about how they designed this camera, or at least looking at its properties, which is really interesting. You'll also see the development of another set of games. So this was starting with a Nintendo system, but continued to a huge degree here. Different genres of games that are very different input-wise. So you have role-playing games like this one, Chrono Trigger. Started out with Dragon Quest and the Nintendo, but really achieved prominence with the Super Nintendo. And the idea is, you may not be controlling a character moving left and right, jumping up and down, like those old games, or firing a spaceship to fire at aliens or something. Now you may be controlling people in a plot-based game. You may not actually do anything. You may just tell your characters what to do. So in this game, if you want your character to attack someone, you press a button and you trigger the action, as opposed to doing it yourself. And this is something that becomes more and more common, that people now have menus to tell other characters what to do, to kind of pick choices of actions. And so these actually are all pop-up menus. They don't pause the action, but I think you can make them pause the action as well. And these games are interesting because they really need complex displays. Everything is numbers-based, so you need to have little pop-up numbers over these enemies to show how much pain you're putting on them. You need to have them on yourself to see how much you have left before your character dies. All sorts of displays all over the place. And now all of a sudden they start caring about how to make them look good and how to make them intelligible. So it's not just that we have a bar here to show when your person's going to move. We now have a bar here that looks kind of nice and at least is obvious what's going on, and it kind of builds up in a really visually pleasing way. We see crazy menus start to appear. Like here's an icon-based hierarchical one. Each of these icons is a different submenu you can pick, and there's submenus within them. They kind of pause the game, let you do different things, and of course you can see the emphasis on numbers once again in this particular one. They give you all sorts of really complex information in an overlay. So whereas PCs right about now, we're well into Windows and pop-ups and actual mouse pointing devices, you really don't see anything like that in games at all. They're still working within the affordances of a directional system. You have a joystick that goes only up, down, left, right. How do you make a menu that works for that? And how do you make it work within a game where you may not want to have action going on beneath your menu? They don't want much hierarchy either, because it turns out hierarchy is really hard to navigate with one of these little controllers. You want enough that you don't have to click a lot, but you don't want too much that you have to constantly go through and back and forth between menus. Here's another one that's also kind of hierarchical in text form, and you can see once again a bunch of numbers and a bunch of different stats that characterize this particular genre. It's once again modal and pauses the game. Meanwhile, another game company also came up with something. This is a little bit out of order, but it's basically Sega was another game company that wanted to compete. They eventually were able to by reducing the price to $189 instead of $199. Pretty exciting. And there are a lot of really bizarre games for this system that explore really strange interaction techniques. If anyone can guess this game, I'll be amazed. But the idea here is you can cast spells, you can explore this strategy, and they have all these bizarre menus with counts that just pop over. This is one of the first pop-over menus I've seen in a long time in games. And weird displays that make no sense, even if you played the game. So a lot of experimentation going on here, too, with menus that don't make sense, hierarchies that are way too deep, a lot of mistakes made. But one thing to think about with the Sega Genesis is the controller. So the Sega Genesis only had 3 buttons, A, B, and C here with a directional pad. It's a little dark, but the thing to note is this directional pad on the Sega controller is very different looking from the Super Nintendo one. That's because Nintendo would have sued them to oblivion had they actually made it look anything like the original because of the patent issue once again. My question to you is, which one of these do you think is better designed for game playing, better designed for the kind of corded interactions we've seen before and the kinds of complex interactions are starting to develop? There's no right answer here, but any thoughts of why one may be better than the other? Yeah.
Well, I don't know how you would ever push all 3 buttons at once on the Sega Genesis, where that's totally possible in the Super Nintendo.
Yeah, so there's the funny thing, I think, with the Super Nintendo is that they realized that the Mario players were all using this kind of 2-thumb approach. And so they made all of the games have people run using the spot on B button. But then you could also press the Y with the tip of your finger again. And they've even gone so far as to make these top buttons have a divot inside of them, whereas these kind of push out, so that you can easily target your fingertip versus the joint of your thumb. So there are all sorts of little subtle design decisions here that are made to kind of accommodate the interaction techniques you may find. And yeah, I don't know any Sega game that even lets you press 2 buttons at once and actually is successful, just because it's really not designed for that at all. And there's also a question of what you do with 3 buttons. This already had a problem doing 4, but in any case, another thing you'll notice is that arcade games actually came back. And this is where we get to really crazy complicated interaction techniques for taking action. So a game like Street Fighter really revolutionized it because now all of a sudden games were once again a social activity. You had characters, 2 different people fighting each other in a social space, and it was actually skill-based. So the reason it's skill-based is because you have a ton of buttons. So you divide this in half in the bottom, and it's kind of one person and the other person. And each button does a different thing. And even better, in combination, the buttons will do other things. So for instance, if you use the joystick and kind of swoop it in a direction and then press a button, you'll do a special move that requires some skill. And so all of a sudden now, it wasn't just about kind of timing your jumps at the right time and making the right pattern of moves. It was actually doing combinations and chords that showed some skill and showed some experience. It also helped that these arcade systems were really, really low latency. So the difference in time between moving and actually taking an action was really, really low. To the point where it actually felt fluid. These games would not have worked otherwise. And of course, in the same arcade revolution, you can see other things, like racing games come out. Now all of a sudden, they're designing controllers that look like the things they're trying to control. So you have racing games with steering wheels and pedals down below. And you've got shooting games where you can actually pick up a gun that recoils in your hand and may even have a little pedal to let you kind of step out from hiding so you can take a shot or something like that. They got very, very complex very, very quickly, and the space of interactions you could make across all the arcade games got very huge just because there was so much variety. To close us for the day, I guess, we'll talk about the PC for a second because obviously this was still happening while all these game consoles were developing, and some of the PC owners were a bit envious. So in 1987, this is an interesting ASCII-based game, so it uses the characters in your command line to draw kind of a dungeon that you can explore. You are this little happy yellow smiley face here, and these O's with the dots are enemies, and the A's are different enemies, and you just kind of have to avoid them and get to the end. You'll notice that they've got already the on-screen display as we've seen before, but also keyboard accelerators, right? This is a keyboard, it's not a controller, so now we can let you press the W key to use a whip for some reason, and a T to teleport somewhere. The input space is much bigger. Of course, there was no mouse here, so you had to use the meta keys to kind of get to this menu. This is 1987, so they didn't really think that was a good idea to use quite yet. Once the mouse comes around, you see the text adventure go away a little bit, and now all of a sudden point and click adventures come around. So the challenge here is not what verb do I use. This is Sam & Max, by the way, another really great point and click adventure game. Now all of a sudden, instead of just typing in what you want to do, you've got to click on the right thing. So do you click on that TV in the center to get what you want to have happen? Do you click on the door to get what you want to have happen? You can now use drag and drop to kind of pick things up off the screen and put them places instead of typing, put the pen in my bag, which you'd have to do before, and hopefully remember that you had it. And so the big challenge here is just remembering what kinds of things you're supposed to be doing, because obviously the developer isn't telling you what to do. You've got to kind of explore and find it out yourself. Other games start to use the Windows prototypes, because Windows 3.1 came out now. So here's SimCity. This is 2000, so it's a little bit newer, but the same still holds. You've got a palette now. So someone looked at the widget kit for Microsoft Paint and realized, oh, hey, the palette's a really good idea for building cities in a game. So they're going to use that. And so now you have different things you can draw on, kind of prefix style. You can pick power lines and then draw power lines across the screen. Or similarly, you can undo and redo. And note they now have keyboard accelerators too. So the PC games are happy to take on PC conventions, whereas the console games really never bother. It goes pretty far. So here's a really silly game from the early 90s called Castle of the Winds, where someone clearly had discovered the Windows widget set and was really excited by Windows 3.1. So all of your inventory are little icons like in an Explorer window. You drag and drop them to equip them on yourself and use little arrow keys to move around. So they're clearly trying to take advantage of the new technology as best they can. This game usually has 6 to 8 windows open sometimes because they figured Windows were the best and you're going to love it and you're going to move them around and do whatever else you want. To close us out in just the last minute, a big thing to mention is the game Doom, which is a 3D first-person shooter game. And so now all of a sudden you can move in a 3D environment. There's no mouse here. It's all keyboard-based in these first games. Mouse could be later added, but in this case it wasn't. You can't even jump, actually. All you can do is move through a 3D environment, which is pretty miraculous for 1993, and kind of explore an area, shoot enemies, that sort of thing. Remember this example because we're going to be coming back to this a few times. But you can see just how rich this display in the bottom really is. You've got different percentages, you've got different values. You can press number keys to get up different abilities and weapons. And so this becomes kind of a trend that's being set, where they're using the full capabilities of the device and the full capabilities of the interactions that they have available to them. So I'm going to leave it with there. We'll start with kind of a quick 20-minute end up next class of just finishing up interactions. We'll get into the Connect and the Wii and some things like that. And if you have any examples you think I should talk about, by all means email me or talk to me on Friday. Cool. I will see you guys later.